Hello, good evening, Dr. Sanders. So here we have our the fractal terrain generator and modifier assignment project done, and we were able to accomplish mouse manipulation as well as uh, the like how you can manipulate the terrain using keys. So I'll first show the mouse one, which is through this. Originally it was flat, but the terrain was flat, but as you move it, oh, as you move it, let's drag it up here. As you move it across the screen, um, you can notice, like, let's say we move it up, it starts to flatten right there. And then under, you can see this part, starts when you move it this way, it starts to move up like this part. So up here, it's like almost flat, and then it starts to move up when you drag it down. And yeah, um, this part is the mouse drag, and then we also able to implement the uh, one where you use keys. So I'll show raising, flattening, no, raising, lowering, and flattening the terrain. So the terrain is originally flat. It looks like this. Then you're able to add a heel manually, burrow manually, and then like you can flatten a heel as well if you so desire. Um, so here we're running. Let's see if I want to raise that, and let's select coordinate 90, coordinate 100 for that, the Z, and then say we raise it to 5. Let's say 75, and then we want to um also raise another one at 100. At 100, 100. Let's give it the same strength, 75. And then we're gonna flatten that one that we just made. So let's flatten it, 100, 100. Let's flatten it by 25. Or yeah, 25 is a good one. And then let's do one for lowering. Not at the same spot, but let's say 75, 75. And let's give it 40 strength and save that. So it gets saved into this fractal terrain manually done. And as you can see, they're pretty close together, but um, this was the raised one. And then next to it, it was raised, then we flattened it. And that's how the top looks. And then this one shows the bar at the bottom, but you can see down here, that's how down it goes. It's a different color just to show um, the change. But yeah, so that's the bottom, and then this is the top as adjusted. So depending on, you can go crazy and just type it out. But yeah, now let's head over to that's the wrong document. This is the correct one. The portion of code that I worked on. So this one is for the mouse tracker file. Um, So what I worked on was the new class that we initialize object view, and then just it's the class's properties, and um, we initialize the width and the height of the panel at 800 and 600 respectively, and then initialize this window, this long data type called window, uh, long, no, this variable called window. And then the camera, we initialize the X angle and the Y angle to 0, and then the distance to 5. And then we also initialize a double. last mouse X and last mouse Y, which is on the mouse coordinates X and Y. And then also we initialize a Boolean called mouse dragging, so which is automatically set to false. And then at some point it gets switched to true depending on a different scenario. And then we initialize a double called the scroll offset, which is just a variable to store the scroll input. And then here we have a private void initializer, uh, which first of all, it's to initialize the 3D graphic window that is our mouse dragging terrain gets fractal terrain gets drawn on. So if it's not initialized, then we throw this exception. And then this one just like initialize a new long called window, and then it creates the graphic window with the width and the height, and then the name, the titles, object view, and then everything else gets initialized to null. And then if the window is null, then we throw a new runtime called failed to create the window. So it's just like kind of like this, but this one's after, let's say the window is initialized, but the window is null, the value of the window it's assigned is null, then yeah, it gets created to null. Then this is just to these are con this is a function that we created called make context. Well, not what we created that came with the LWJGL. And then this is swap interval, and then show window, which renders the window, and then this is just a depth test, and then it enables that. And then this is clear color, so it makes um, the color for the background. And then um, this just sets scroll back uh, for the sake of zooming. Okay, so I'm sorry, I got a phone call. As I was saying, this one, so just enables the depth uh, of the image getting created, and then this just sets the color of the background, and then this sets the scroll back, and then uh, this sets the scroll offset to Y offset because that's the one that controls up and down. And yeah, and then the next thing I worked on was just this, which is also part of the scroll offset for zooming. If it's a not zero, then the camera distance gets subtracted by the scroll offset by multiplied by 0.5. And then if the camera distance is less than one, then um, we make sure the camera distance does not go over one. And then after applying that scroll offset, then we reset it back to zero. And then this part is just in running the object viewer object, the yeah, the this method, this class method. And then for the manual one where we were able to use keys to edit our terrain, the main thing I worked on was the modify terrain portion. And here, so first of all, we initialize uh, the size and radius as so uh we as you saw here. Let me quickly go back here. Our terrain, when we select a point to modify, it's a circle, and so um here's where we're initializing that radius, and then we initialize the size uh as the height map domain, which is I think 800 units in this case. And then here we have two for loops. So one that goes that runs across the x-axis from the middle of that circle to the end of from the end of the x-axis to the center and then to the other end of the x-axis. And then the same thing for this z-axis. And then this is just a called distance that is found um, uh, with when we multiply the radius squared and the radius of the z squared as well. And yeah, I think that's like like how a triangle works. Yeah, similar way. And then if distance is less than or equal to like radius, then we switch mode. Uh, we initialize the switch called mode to lowercase. So if somebody does raise, even though it's caps lock or it doesn't matter. If the case is called raise, then that's when we do this raising thing where the x coordinate and z coordinate get updated with the strength times one minus the distance over the radius. Same thing about lower, but this time it's for raise it's addition, then lower is subtraction. Then to flatten is just like applying strength at the top or the bottom of the terrain that we just uh, manipulated. And yeah, that is the main thing, and I don't think there's anything else. Thank you, and it was quite a learning experience. I enjoyed it.